Hello everybody, I am Oscar and I welcome you to this series of videos about how to communicate with the Cardano node. The goal of this project is to provide you with enough information about the Shelley networking protocol so that you can implement your own version of it. These videos do not intend to teach you how to use common clients for the Cardano node, as would be the Cardano CLI or DB-Sync or any other third-party software that communicates with the node. It is for you to get some insight into the specification. Let us start by viewing the architecture of the system we're going to be working with. It all starts with our Cardano node communicating with peers in the Cardano network and participating in the distributed consensus of the Cardano blockchain. In general, it is not enough to just have your node running because you want to interact with it, communicate with it, extract data from it. What we do for that is to use the most basic client we have available, the Cardano CLI, which we can use to query the node, build transactions, submit transactions. Generally, this workflow is too cumbersome, and we tend to develop tools to deal with the Cardano node and the Cardano CLI to make our lives easier. Those tools could be, for example, a project of my own, the Cardano transaction editor, which wraps the Cardano CLI to give you a nicer interface. But you can implement wrappers around this middleman to interact with the node in ways you would prefer. But there are other alternatives. For example, you could connect the node through the Cardano DB-Sync, which transfers the state of the Cardano blockchain to a Postgres database, which then you query for any information you might need. This also allows you to provide web applications or any other service that talks to a database. And there are many more clients that talk with the Cardano node, like the project from TXPipe, Ura, or from Cardano Solutions, Cardano Ogmios. All of them talk with the Cardano node and open an API that can be ingested from any of your applications. The goal of this course is to teach you about this first link. How does your application manage to talk with the Cardano node? The largest source of information is, of course, the implementation written by IOHK. This document, the Shelley networking protocol. It is an interesting document to read and will give you all the information you need to implement the specification. I will use this document to showcase some of the information about it and give you a practical example of its implementation. Before we jump into the Shelley networking specification, let's talk about the tools we're going to need for our work. This is where these videos become opinionated. First question we have to ask ourselves is, what is the work about? What are we going to do? And I would argue we are working on human knowledge. The specification is human knowledge. The implementation is human knowledge. Human knowledge is encoded in language, whether it is English or any human-based language, or Haskell or any machine-based language. They all encode human knowledge. And we encode languages in text. And for that, our most basic tool is a text editor. And I'm going to do the recommendation and use throughout this video series, the Emacs text editor. It is a wonderful editor with a long history, probably has been around longer than you. It is certainly older than myself. And it has outlived many editors. And my experience has shown me that certainly the most powerful feature of anything, it is how well it survives the passage of time. And Emacs has a great track record. Finally, it is an open, extensible, and freedom-respecting software that is extremely valuable and guarantees you this software will be around. Now, why Emacs? Or how did I even start it on it? Why am I advocating for Emacs? For many years, I have been a happy computer user, using individual applications for every task. I use my integrated developing environment for programming, my word processor for writing things, my email client to deal with email. And it wasn't until I had to edit files on remote machines that I dwell into the VI editor. Vim VI is great for my work, editing text, working with human knowledge. And I wish I could use it more often, in more places. And that's what drove me to Emacs. It is an ambitious text editor that could take easily over my work. I could do all my work without ever leaving Emacs. It didn't only sneak into my work, it became my workflow. And I wanted everything to be text so that I can use Emacs to work on it. Finally, I discovered that Emacs is not a text editor, but it is building material. This is where the feature of extensibility comes into place. You can use it to create what you want. And that is what is going to be so useful in this class, because it is about how we put ideas into words. When you want to work on an idea, prototype on it, you want quick feedback. And in the case of writing an implementation that a computer will understand, you want an interactive language. Python. Python was my language of choice. It's interactive, it has a wonderful ecosystem, lots of libraries. It takes care about many things, letting you prototype your system. And it was my best option until I discovered Lisp. And Lisp is an old language that refuses to die. We still use it. Lisp is also an idea more than a language, and thus it has many implementations and many dialects. And each dialect is targeted at a specific problem, at a specific application, goes under a specific philosophy. I will use in this video series Emacs Lisp. The reason for it is because it is integrated in the editor into Emacs. As I said, Emacs building material.